Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss the very important topic of differential equation of first order and first degree, that is an exact and non-exact differential equations. So, I have discussed about exact differential equation in last videos. How we can check that a differential equation is an exact. What is the property of a differential equation which is an exact? So all formula, all property we have already discussed in last video. Now at present I want to solve some problem on exact differential equation. So here I will discuss some problems based on an exact differential equation. This is problem 2. Some problem already I have solved, but now more problem I want to solve here. So problem 2 based on an exact differential equation. That is very easy topic and interesting also. Easily we can solve this question. Now question is here y square minus x square and dx plus 2xy and dy equal to 0. This is given differential equation in question paper. How we can solve this question? So this is the equation of the type m dx plus n dy equal to 0. Our given question in based on given this differential equation. Equation 1 and equation 2 both are same equation. After comparison comparing in equation 1 and 2 we get m is this m by square minus x square and n is 2xy. Now if a differential equation is an exact, then this verify the condition del m over del y equal to del n over del x. This is the condition of partiality. This is the condition of an exact differential equation. So first of all we want to derivative del m over del x, del m over del y means differentiating m with respect to y and differentiating n with respect to x partially. Then we get here m equal to y square minus x square. So differentiation of m with respect to y means x as a constant. So x as a constant, differential of x is 0 and y square is 2y. And now differentiating n with respect to x, y as a constant. So y as a constant, x differential of x is 1, so this is 2y. Here we see that del m over del y is 2y and del n over del x is 2y. Here condition of an exact del m over del y equal to del n over del x. So this condition is verified. This is the condition of an exact. This is the condition of an exact. This is the condition of an exact. So given differential equation is an exact. We have proved that the given differential equation is an exact because the condition of an exact is verified here. Okay. So find the solution of given question. We apply following 3 steps. Easily steps we apply to find the solution of the question. Now step 1, integrating m with respect to x and by keeping constant here. In first step we integrate the value of m with respect to x keeping y as a constant. This is step 1. And step 2 So now here question is m equal to y square minus x square and n equal to 2xy. So property of exact del m over del y equal to del n over del x. So now differentiating del m over del y equal to del over del y of y square minus x square here. X is a constant. So del over del y of y square only and x square 0. So this is 2y. And del n over del x of 2xy. Here y as a constant with respect to x, y as a constant. So here y del over del x of 2x. So differential of x is only 2y. So del m over del y equal to del n over del x. So this property is verified. So the given differential equation, differential equation is an exact. Okay. Now solution process. Step 2, integrating n with respect to y, taking terms in n not contain x. Step 3, y equal to step 1 plus step 2 plus constant, arbitrary constant c. So now solving step 1 here. I am solving step 1. Step 1. Integrating m is y square minus x square dx. Y as a constant. So here y constant means y square integration dx minus x square integration dx. Now y square x minus x cube by 3. Okay, this is step 1. This is solution of step 1. Now step 2. Integrating n dy, not contain x. What here? N equal to 2xy. So in n x is present. So taking n equal to 0. So in step 2, integrating 0 dy. So this result is 0. Now step 3 is y is equal to step 1 plus step 2 and plus c constant. So y is equal to step 1 means y square x minus x cube by 3 and plus c. This is the solution of the question. Step 1 is this. This is solution of step 1 and this is the solution of step 2. This is step 2. Now total is step 1 plus step 2 plus c. So y equal to not by equal to step 2. So step 1 equal to c. This not this. This equal to c. Here this c. Step 1 plus step 2 equal to c. Because formula is this integration. Now problem 2 based on method on exact differential equation. This is same question based on exact differential equation. So now solving here. First of all solution here, x dx plus y dy equal to a square x upon x square minus y square into dy minus a square y dx upon x square minus y square. So here is dx and here is dx. Dx taking common. So in bracket x minus a square y upon x square minus y square and dx plus here dy and here dy. So this taking this side, this is plus, this taking this side, this is minus. So here y minus a square x upon a x square minus y square and this dy equal to 0. So this equation, this is one question, this is 1 and this equation 2. Now this is m dx plus n dy equal to 0. Comparing on both sides. Comparing this equation number 3. Comparing in 1, 2 and 3. Then we get now m equal to x plus a square y upon a square y upon x square minus y square and n equal to y minus a square x upon x square minus y square. So after comparing, we find value of m and value of n. Now differentiating m with respect to y, x as a constant, with respect to y, x as a constant. So we get del m over del y, x as a constant. So this result is 0 plus a square and differential of this numerator and denominator using formula numerator and denominator formula. So here denominator x square minus y square, differential of numerator is 1 minus numerator differential of denominator is minus 2y upon denominator का whole square x square minus y square का whole square. Here we apply the formula d over dy of f1 upon f2. So f2 differential of f1 minus f1 differential of f2 upon f2 का whole square. We apply this formula. So we get this. So here is a square and in bracket x square minus y square plus 2y square. So upon x square minus y square ka whole square. Now a square and this x square plus y square upon x square minus y square ka whole square. This is del m over del y. Okay. Now similarly n equal to y minus a square x upon x square minus y square. So differentiating n with respect to x, y as a constant, So now del n over del x, this is equal to differentiating with respect to x, so this 0 minus a square and denominator x square minus y square, differential is 1 minus x into 2x upon x square minus y square ka whole square, and this equal to a square minus a square in bracket x square minus y square minus 2x square upon x square minus y square का whole square. So now this equal to minus a square in bracket. Here is minus y square and minus x square upon x square minus y square का whole square. So minus multiply here x square plus y square add into a square upon x square minus y square का whole square. So this is del n over del x. Now this is equation number 3, 4 and this equation number is 5. From 4 and 5, from 4 and 5 we get del m over del y equal to del n over del x. This is the condition of n exact. Condition of n exact. So given equation is an exact. So given differential equation is an exact. Okay, exact. Now using formula of n exact. Number 1, step 1, integrating m with respect to dx, y as a constant, So integration m, what is m? M we check here, what is m? Y minus a square x upon x square minus y square. Y minus a square x upon x square minus y square का whole square. This is value of m. And so integrating this result with respect to y, x, keeping y as a constant, integrating m with respect to x and y as a constant. So now y is a constant, integration here, y constant by this, and here dx, 1 dx, minus here a square constant and x constant here, x constant, integrate x upon x square minus y square, This is n whole square. What is value of m? Not whole square there. This is not whole square. Okay. X square minus y square and dx. So here y is a constant. So here we apply formula here, minus 1 minus x square. So here formula is 1 minus x square, y square as a constant. So 1 upon a square, ये प्लस तो नहीं है, क्वेश्चन में क्या है यार, माइनस है, प्लस होगा यहाँ पर प्लस होना चाहिए, माइनस है, 1 minus x square sin inverse. So now integrating this x square minus y square, wrong question हो गया, तो यहाँ पर इसका 2x, okay, log. So here integration of this dx, integration of x square minus y square dx, y is a constant and here x, so इसका integration आएगा 1 upon 2 log x square minus y square, y is a constant here, so 1 upon x square minus y 2x, इसका integration, so here yx minus a square and upon 2 log x square minus y square. This is the this is the integration m dx, step 1. Now step 2, integration n dy, not contain x, not contain x. So here in n, what is n? N is y minus, this is n, m is this, and n. This is wrong हो गया यार. ओके यहाँ गलत, ये now I have taken wrong value of m. So now value of m is this, m x plus a square y upon x square minus y square. So here value of is x plus a square y, integration m. So x plus a square y upon x square minus y square, and here is dx. This is dx. Okay. So now x square minus y square dx. So integrating this, y as a constant here. So integrating x means x square y2, and plus a square, integrating of this y as a constant. So y is common, 1 upon x square minus y square. So dx. Okay. So here this x square upon 2 plus a square y, and now integrating this, 1 upon minus common, we have taken minus common, and integrating 1 upon y square minus x square dx. So 1 upon a square minus x square and integrating dx. So this equal to log a plus x upon a minus x, this formula we apply here. So x square y2 minus a square y, and 1 upon 2a, 1 upon 2a. So 1 upon 2a means y, and log y constant y plus x upon y minus x. Okay, so by y is cancelled. So x square y2 minus a square y2 and log y plus x upon y minus x. So this is the solution, step 1. Okay, m dx. Next n dy. So here integrating n dy, n dy, not contain x. So in this term, what is n? In n is this second term totally have contain x. So n dy, only be taking here y. So be taking here n dy. This is step 2. Step 2. N is only y. So dy equal to y square y2. Now step 1 plus step 2, this equal to constant. So step 1 solution, x square y2 and minus a square y2 and log of y plus x upon y minus x and plus step 2 y square y2 equal to c. So this is the solution of given differential equation. Now next topic is non-exact differential equations. Non-exact differential equation means those differential equations which are not exact, means those differential equations which are not verify the condition of an exact. This condition is not verified in any differential equation, then that is known as a non-exact differential equation. Or we can say that reducible to exact differential equation, means these equations can be reduced in an exact differential equation. So definition, a differential equation which is not satisfy the condition of an exact, then differential equation is known as a non-exact differential equation. Means here del m over del y is not equal to del n over del x. This condition is not verified in a differential equation, then that equation is known as a non-exact differential equation. So there are 5 methods to solve non-exact differential equation. Here we will discuss one by one method which given differential equation, when given differential equation is not exact, then how we can solve the one by one method we are discussing here. So now first method, when a differential equation is not exact, then first method which is applied to solve the differential equation, that is known as the inspection method. Inspection method means we are doing work as an inspector. What is the condition? What we apply the condition here to solve the question? Nothing we are doing. Some formulas we have already some formulas. With the help of this formulae, we are taking situation. What is the condition of the question? Which formula is applied in the question? So this is known as a inspection method. Okay. So in this inspection method, some part of differential inspection method means there is some part of differential equation is a differentiation of some function. Without checking exact, we apply direct formula in this method. But the given differential equation must be non-exact differential equation. Then we apply this formula. We will use some important formulae in this method. So now formula is, suppose here x dy plus y dx. This result is written in any differential equation. Then we can write differential of xy. Okay. Next formula is x dx 2 x dx plus y dy. So we can write this 1 upon 2 differential of x square plus y square. Because if we differentiate this result, 2x dx and plus 2y dy. So 2 is cancelled, x dx plus y dy. Here x dy plus y dx. Now next formula. Here y dx minus x dy upon y square. So what is this? This is the differentiation of x upon y. This is numerator and this denominator. Formula होता है इसका denominator y differential of numerator dx minus numerator differential of denominator upon denominator का whole square. So in any term, this term is given in our question, we can write this. Similarly, next formula is x. This is the differential of x dy minus y dx upon x square. So this is the differentiation of y upon x. Next formula, this one is y dx minus x dy upon x square plus y square. So formula this one is differentiation of tan inverse x upon y. Okay, how we can write this formula? Next, this one x dy minus y dx upon x square plus y square equal to differentiation of tan inverse y upon x. This is formula. Okay, how we can write this formula? I can prove it. X dy minus y dx upon x square. X square taking common. So this is 1 plus y square upon x square. So y upon x is t. So 1 upon 1 plus t square. So d of y over x is dt. So this is d of y over x. So this is dt. dt upon 1 plus t square integration. This is tan inverse t. This is tan inverse t means y upon x. So this is formula is this proved. Okay. X dy minus y dx upon x square plus y square. Here x square taking common. X square taking common and 1 plus y square upon x square. Let here y upon x equal to t. So differential of y upon x equal to dt. So here this is d of y over x, and this is 1 upon 1 plus t square. Y upon x is t, so dt upon 1 plus t square tan inverse t equal to tan inverse t, and this is tan inverse y upon x. So similarly, next is here 3x square y dx, 3x square y dx plus x cube dy. This is the formula of d of x cube y. Here we can use product formula. Product. So differential of x cube means 3x square and dx, and y is constant plus x cube constant differential of dy. So this result is equal to this here. So here e की power x, differential of e की power x का e की power x and dx into y constant plus e की power x constant dy. So this is formula is this. Now similarly same formula is this. So there are several formulae which are based on inspection method. So here we discuss the problem based on method 1, inspection method, for non-exact differential equation. If we check this differential equation, this is also non-exact. Suppose I am checking here. Here is dx, 3x square y and dx and plus x cube plus y square dy. So now here m is 3x square y and n is x cube plus y square. So del m over del y, differentiating with respect to y, 3x square. Differentiating with respect to n, x, del n over del x, this equal to 3x square. So this is exact. This is already exact differential equation. So this is integrable. Okay. This is already integrable. So here we can say that this result, this differential equation is the differential of some function. So here we write this d of x cube y, this result, and plus this y square dy. Okay, integrating on both sides. So this result x cube y and plus y cube by 3 equal to c. So this is the solution. If this is inspection method totally applied here, then that is already an exact. Okay. Now, this is inspection method. This is already exact. This differential equation is an exact because inspection method is applied here. Inspection method is applied means in differential equation, function is the differentiation of some function. So this result we can write here. What is this? This is here y square is common. So y dx minus x dy upon y square is common, and here 1 plus x square upon y square. So this result, and plus in this result y dx minus x dy upon y square equal to 0. Now next result here, this result, integrating on both sides. So integrating on both sides, what is this result here? Y upon x upon y. X upon y, this is the x upon y. We can write here integration differential of x upon y and upon 1 plus x square upon y square, and plus this is the differentiation of x upon y also. So here differentiation, integration differentiation of x upon y also. equal to C. Clear? Now this y dx minus x dy upon y square. So this is the differentiation of x upon y, and this is also differentiation of x upon y. I am writing this type here. X upon y, y dx minus x dy upon y square upon 1 plus x square upon y square. This result. So here we write this d of y upon x upon y upon 1 plus x y ka whole square, and plus this differential of x upon y equal to C. So this is answer is x upon y. Here let x upon y is equal to t. Then this result is dt upon 1 plus t square. So equal to C. So this is tan inverse t plus x upon y equal to C. Tan inverse x upon y t. What t is? X upon y plus x upon y equal to C. This is solution. Okay. Now next, the given differential equation is not exact, and condition of an exact this not verify is not verified. Then now we multiply by a function fx to the differential equation. Then differential equation convert in exact. The differential equation change in an exact, and also verify the condition this of an exact. Then we can say that function fx is known as a integrating factor of the given differential equation. Means in a given any differential equation is given to you that is not exact. If we multiply by some function, that is say fx, and after multiplying by fx to the differential equation, and differential equation convert in exact, and it is verify the condition of an exact, then this function is known as a integrating factor of the given differential equation. So now here we find out some integrating function of a differential equation with the some methods. Now method 1, here we apply method 1, method this 2. In this second method, what we are doing in a question is step 1, del m over del y minus del n over del x, del m over del y minus del n over del x. This is the property same, but we are writing here minus sign, and divide by n, and this equal to, suppose this is the function of x, is the function of x here. So now say fx this. Now what is if? Step 2, multiplying by this if to differential equation, then differential equation becomes an exact. So here this fx, now taking integrating factor, this is e की power integral fx dx. So this is an integrating factor, and multiply by this function to the differential equation, then differential equation becomes an exact. Step 3, solving differential equation by the method of an exact differential equation. So this is the process. In step 1, we apply this formula. This is a some function of x. We find some function of x, del m over del y minus del n over del x, divide by capital N, is a function of x alone. Nothing function, nothing other variable y, only function of x, say fx. Then integrating factor if equal to e to the power integral same this fx dx. So this is integrating factor. Then why this integrating factor? Why this integrating factor? multiply to the differential equation, then differential equation becomes an exact. Step 3 is solving differential equation by the method of an exact differential equation. Now, here problem 1 solve based on method 2. So what is problem? Problem is this: 2x log x, 2x log x, 2x log x, 2x log x minus xy dy, minus xy dy. Okay, and next plus 2 by dx, plus 2 by dx equal to 0. First of all, this is non-exact differential equation. Here m dx plus n dy equal to 0. This equation 1, this equation 2. This is general equation and this is given question. Now comparing 1 and 2. Comparing 1 and 2, we get, so m, what is m? M is 2x log x minus xy, and n is 2y. Differentiating with respect to y, x as a constant, x as a constant. So we get del m over del y, this equal to x as a constant, this total 0, x as a constant, y with respect to y, so minus x, and del n over del y, del n over del y, y as a constant, del n over del y, x as a del n over del x, sorry, del n over del x, y as a constant. So y as a constant with respect to x, so 0. So del m over del y is not equal to del n over del x. So given differential equation is not exact, given differential equation is not exact. Now step 1, apply step 1, del m over del y, apply the formula del m over del y minus del n over del x upon n. So del m over del y is minus x, del m over del y, this is the total function of x, so this is 0 with respect to y, del m over del y, and minus xy. So x constant, y के respect में x is constant and y का 1, so minus x. Here is minus x and minus 0 upon n. N is, what is n? N is 2y. Upon n means 2y. So minus x upon y. This is, here is minus x upon y. But यहाँ y आ रहा है. Minus x upon y. This is x, del m over del y equal to minus x, and del n over del x equal to 0. Del n over del x equal to 0. Here is not x, only y, so 0. So del m over del y minus del n over del x. Del m over del y is minus x, and del n over del x 0. So upon x is only 2y. So this is not only x. This should be function of x only. This is function x only. So here अगर यहाँ एक्स वाई लिखेंगे तो भी ये एक्स कैंसिल होगा, ये वाई एक्स आएगा. दिस इज फंक्शन एक्स ओनली. So this is not only, this is must be function of x only, of x only. This is must be function of x only, but here is not x. What is the mistake in question? Just checking here question. 2x log x minus xy dy plus 2 by dx. Okay, I am wrong writing this question. This is m, this is n. Sorry. This question is wrong. उल्टा हो गया. Just I am taking opposite function, so we have problem here. Just question is this here, 2 by dx, 2 by dx, and next plus 2x log x minus xy plus 2x log x minus xy dy. Okay, this is equal to 0. I have taken opposite, so this is mistake in our question. Now this question is correct. We have not have any mistake in this question, please. So comparing, this is equation 1, comparing this m dx and plus n dy, this equal to 0, this equation 2. Now m is 2y, and differentiating del m over del y equal to 2. Okay, and n is 2x log x and minus xy. So differentiating del n over del x. So this differentiating with respect to x. So this equal to differentiating with respect to x, 2 here. Differentiating with respect to x, x upon x and plus log x into 1, log x into 1, and y differentiating with respect to x and y as a constant, differentiating with respect to x to n and y as a constant here. Okay, y, so minus here x, x1 y constant, so minus y, this and minus y. Okay, so this equal to 2 into 1 plus log x and minus y. Clear? Del m over del y equal to 2 and del n over del x. Del n over del x means differential of this product formula, x log x 1 upon x plus log x into 1, this, and minus xy differential with respect to x, y constant with respect to x is 1. So to this. Now we applying here formula here, del m over del y minus del n over del x upon n. This is the function of x only. Then integrating factor if. So now here what is this del m over del y? This 2. And minus del n over del x, this 2 minus 2 log x, 2 minus 2 log x, okay, and minus y upon n. So this 2 is cancelled, and here n. What is n? N is x is common, correct. This equal to minus 2 minus 2 log x. So here multiply n, minus 2, here plus y हो जाएगा, plus y. So here is minus 2 log x plus y, means y minus 2 log x, y minus 2 log x upon में क्या है n? N is total 2, x is common, 2 log x minus y, means correct. So here is upon minus x and y minus 2 log x. So this result is cancelled. Here is only minus 1 upon x only. This is fx. Okay. So now if Integrating factor is IF integrating factor e की power integral minus 1 upon x dx. This is fx and dx. So now e की power integral minus 1 upon x dx. So this is integrating log x, e to the power log x minus sign. So this 1 upon x, this is e की power log 1 upon x. So this equal to only 1 upon x. This is IF. Now this multiply by this function, then our question is integrable. So multiply here. What question? Question is 2y dx, 1 upon x, 2y dx and plus 2x log x, 2x log x and minus xy, okay, dy. Two x log x minus xy dy equal to 0. So multiply 1 upon x here. So in 2y upon x dx and plus 2 log x dx dy and minus y dy. Okay. So here this is integrable function and this function is not integrable, this one. So now here differentiation clear हो गया ना ये. So ये हो गया 2y 1 upon x dx and plus 2 is common. So this log x and dy. Okay, log x dy. So this is the two differential of, this function is differential of by log x and minus this is y dy. So integrating on both sides, this is 2y log x and minus y square y2 plus c. This is complete solution. Okay, clear हुआ ना? Again repeat this question here. Okay, question is 2x log x minus xy dy and plus 2y dx. So this is the first term. This is m and this is n. So now we write this one 2y dx plus 2x log x minus xy dy equal to 0. So this equation 1. Now here m dx plus n dy. This is m or this is n. This dx, m dx, m and this n. So now this is general equation. Comparing 1 and 2. Compare in 1 and 2. So here m equal to 2y and differentiating with respect to y here. Del m over del y. X as a constant. So we get here 2 only. Now n is 2x log x minus xy. So differentiating with respect to x only here. So here 2 is constant, x log x. Differentiation of x log x. X constant log x का 1 upon x plus log x का 1 and minus y constant x का 1. So here 2 1 plus log x minus y. Okay, 2 1 plus log x minus y. Now we apply this step 1 method. Del m over del y minus del n over del x upon n. This is step 1. Step 1 here apply. So this is some function of x here. So here del m over del y is 2 minus del n over del x is 2 minus 2 log x and plus y. So 2 cancel, minus 2 log x by minus 2 log x upon minus common taking minus x by minus 2 log x. This total bracket is cancelled. So we get minus 1 upon x. That is fx. Now if integrating factor. e की power integration fx dx. So e की power integration fx, what is fx? Fx is minus 1 upon x dx. So e to the power, this is e की power minus log x. Minus log x means e to the power log 1 upon x. So this is 1 upon x only, integrating factor 1 upon x. If we multiply by this factor to our question, multiply y this function in question, then question is an exact. Question exact हो जाएगा. Okay. So multiply by this function is 1 upon x 2y upon x dx plus 2 log x dy minus y dy. So y dy, this equal to 0. This is the integrating function. Variable separate here. This is variable separate here. So now y square y2 answer. But this result here, to by 1 upon 2 is common. By 1 upon x dx plus log x dy. So this result is differentiation of y log x. Y का differential dy log x constant plus y constant log x का 1 upon x dx. And this. So integration of this is integrating on both sides. Integration of this y log x. So this is answer. Now next problem based on method 2. This is same problem. So here ये तो same question आ गया. 2 log x. There is some mistake here. There is some mistake. Minus x 2 log x. पता नहीं क्या लिखा है. There is some mistake in this question. So I am not solving this question. Next. Now method 3. The given differential equation are not exact and condition of an exact del m over del y and del n over del x is not verified. Then now we multiply. This is not verified. This condition. Then equation is not exact. This condition are not verified. Del m over del y is not equal to del n over del x. So now we multiply by a function fy to the differential equation. Then differential equation convert in an exact and also verify the condition this of an exact. Then we can say that the function is known as an integrating factor of the given differential equation. Now here, now using step 1. In this method we are using some steps. Del n over del x minus del m over del y upon m is a function of y alone. Say fy. Then integrating factor is this. Integrating factor I have. This is e की power integration fx fy dy. Fy and dy. Function of y only. So step 2, multiplying by this if to differential equation. Then differential equation becomes an exact. Solving step 3, solving differential equation by the method of exact differential equation. Okay. Problem based on method 3, solving this. y4 plus 2y dx. y4 plus 2y dx and plus xy cube plus 2y4 plus xy cube plus 2y4 xy cube plus 2y4 minus 4x dy equal to 0. Okay. This is given question. 4x dy equal to 0. This is equation 1. Now m dx plus n dy, this equal to 0. This is equation 2. This is general equation. This is given question. Now comparing in 1 and 2. We get value of m. M is y4 plus 2y, and n is xy plus 2y4 and minus 4x. So differentiating m with respect to y, x constant, x as a constant. So del m over del y, this equal to 4y and plus 2. This is m. Now differentiating n with respect to x, y as a constant, so del n over del x, this equal to y as a constant. So here is y cube and this 0 and minus 4. Okay, y as a constant. So differential of y is y as a constant. Differential of x is 1 y cube minus this y constant minus 4. Okay, so del m over del y is not equal to del n over del x. So given differential equation is not exact. Here we multiply step 1. Del n over del x minus del m over del y upon m. This is the function of y only. So now finding function del n over del x. What is del n over del x? Del n by cube minus 4. By cube minus 4 minus del m over del y. Del m over del y means 4 by cube plus 2 minus 4 by cube minus 4 by cube plus 2 minus 4 by cube plus 2. तो ये माइनस 2 हो जाएगा, माइनस 4 by cube minus 2 upon n. What is m? M is y की power 4 plus 2y upon m. Upon m means y to the power 4 plus 2y. So now this equal to here, this is the function of y only. So here 4y cube minus y cube, 4y cube minus y cube minus 3y cube minus 3y cube, 3y cube, 4y cube and plus y cube minus 3y cube and minus 6. Okay, minus 4 minus 2 6 upon y is common, so here y cube plus 2. So here is 3 common, minus 3 common, y cube plus 2 upon y into y cube plus 2. So this cancel. So this is minus 3 upon y. Okay, this is the function of y. We get function of y only this. So now integrating factor, this e की power integration fy dy. So e to the power integrate minus 3 upon y dy. So e to the power minus 3 log y. So this e to the power this equal to e to the power log y की power minus 3. So this equal to e to the power log 1 upon y cube. So this equal to 1 upon y cube only. This is IF, integrating factor. Now we multiply y this factor to given differential equation. Given differential equation, then equation must be exact. Equation is an exact differential equation. Exact differential equation. Okay. So now multiply by this IF to each term of the question. So what is question here? Here question y4 plus 2y 1 upon y cube, y4 plus 2y, one upon y cube in bracket y4 plus 2y and dy dx plus xy cube plus 2y4 xy cube plus 2y4 and minus 4x and into dy upon y cube equal to 0. So we multiply by this function in each term. Then now integrating. Every term be separate here. Dividing by this here y dx only. Multiply by this. Here multiply by this plus 2 upon y square and dx. Plus here multiply by here x dy by cube cancel. Plus multiply by here plus 2y dy. And plus multiply by here minus 4x upon y cube dy equal to 0. So now integrating this function y dx plus x dy. We are making it y dx and plus x dy. Okay. Now next result is y dx plus x dy plus 2y dy. Okay. Plus 2y dy. This is integrating function. This is also y dx x dy. B can write it d of xy and plus b can write it y square y2. And next function plus here this 2 upon y square dx minus 4x dy upon y cube. 2 upon y square dx. 2 upon y square dx minus this one 4x upon y cube minus 4x upon y cube and dy, okay, equal to 0. So plus here I am writing this one integrating y cube and here 2y dx minus x dy minus 4x dy. Okay. So this what is this? Y to 2 dx and 4x dy. So y square. So this is the xy plus y square integrating this. This is the d of y square. And here y square plus this. What is this differential of this? Here at 2y dx plus 4x dy. 4x dy. So x upon, this is differential of x upon y square. X upon y. Y x square dx. 4x. So this is differential of x upon y square equal to c. So xy and plus y square plus x upon x by अलग अलग डिवाइड कर दो 1 upon y square. y square 2x and 4x dy, 4x by cube, 2y dx minus 4x dy by cube. तो x अपॉन y स्क्वायर हो रहा है, x 2 कॉमन हो गया, 2 इज कॉमन, सही लिखो इसको इतने टर्म को। क्या टर्म है इसमें, कहाँ गया वो टर्म, दिस टर्म हियर इज 2 इज कॉमन, 2 तो कॉमन ले लो इसमें से, 2 इज कॉमन, ओके, इन ब्रैकेट 2 इज कॉमन इन ब्रैकेट, 2 इज कॉमन, तो 1 अपॉन वाई स्क्वायर dx, तो यहां पर आ रहा है x अपॉन वाई स्क्वायर dx, क्लियर, माइनस इधर क्या है 4x, 2 कॉमन, तो 2x अपॉन वाई क्यूब dy, 2x अपॉन वाई क्यूब और dy। एक बार और चेक करो, यहाँ क्या लिखा है 2 अपॉन वाई स्क्वायर, 2 कॉमन, तो x नहीं है यहाँ, here is no x, 1 अपॉन वाई स्क्वायर dx, ओके, और 2x अपॉन हो गया, नहीं हो गया, तो ये हो गया x अपॉन वाई स्क्वायर, मीन्स 1 अपॉन वाई स्क्वायर dx, तो ये प्लस है x अपॉन यानी 1 अपॉन वाई स्क्वायर dx और माइनस वाई स्क्वायर का डिफरेंशियल 2 अपॉन वाई क्यूब, ये हो गया, तो यहां से रिजल्ट आ गया x अपॉन वाई स्क्वायर इक्वल टू c, दिस इज आंसर, ओके, दिस इज फाइनल आंसर ऑफ दिस क्वेश्चन। नेक्स्ट प्रॉब्लम बेस 2, again problem based on method, this 3 same method 3, so here is m dx plus n dy equal to 0, okay, so here now m equal to y x square and y square plus e to the power x into y, and n equal to minus e to the power x, okay, so del m over del y, this equal to differentiation of y with respect to y, x as a constant, differentiating with respect to y, x as a constant, okay, so here is x square constant and 2y plus e to the power x constant into 1 and del n over del x, y as a constant, so minus e to the power x, so both results are not equal, del m over del y is not equal to del n over del x, so the given differential equation is not exact, okay, so now we apply the formula this method 3 here. Step 1, we are using del n over del x minus del m over del y upon n m, this is the function of y only, okay, so here writing value of del n over del x, what is del n over del x, minus e to the power x minus e to the power x minus del m over del y, del m over del y means x square 2y plus e to the power x, x square 2y और minus e to the power x, this is del m over del y, x square 2y, here x square y square का 2y, e to the power x, y is 1, so here upon m, what is m, m is x square y square plus e to the power x y upon x square y square and plus e to the power xy. Okay, so e to the power x is cancel. No, cancel not. So here 2 e to the, this is minus 2 e to the power x minus x square and 2y upon, here y is common denominator में, x square y and plus e to the power x. Here is minus 2 common and e to the power x plus x square y upon y common x square y and plus e to the power x. So this bracket cancel. Here is minus 2 upon y. This is the function of y only. Okay. We apply this formula here. Here this formula. Del n over del x minus del m over del y upon m. So del n over del x is minus e to the power x. Minus del n over del y means minus this and minus this. Upon m. M is this. So here e to the power minus x minus 2 e to the power x minus this. So here minus 2 is common, e to the power x plus x square y, and denominator में y is common, so x square y plus e to the power x. This result is cancel. Both are same results. Cancel. Here is minus 2y. This is the function of y only. So here here we are solving this now. Taking integration IF, integrating factor. Integrating factor is e की power integration fy and dy. So this result is e to the power integrating, what is fy, minus 2 upon y. Minus 2 upon y and dy. So here is minus 2, this is log y, integration of log y, e to the power. So this is e to the power minus log y की power minus 2. So this is e की power log 1 upon y square. So this is 1 upon y square. This is IF. So integrating factor is 1 upon y square. Okay. 1 upon y square is integrating factor. Now multiply by this factor in each term of the question. Question is this. This one. What? 1 upon y square. Integrating factor is 1 upon y square plus. So 1 upon y square multiply here. 1 upon y square means 1 upon y, x square y plus e to the power x. X square y plus e to the power x and 1 upon y only. Okay. This one. X square y plus e to the power x, 1 upon y square, y is cancel here, and dx plus minus e to the power x upon y square minus e to the power x upon y square dy equal to 0. Okay, we multiply here 1 upon y already hai y, y square, y and y square. So 1 y is cancelled. Now this question is integrable. How we can say integrable? Separating this. So here x square dy dx plus here here e की power x upon y dx and minus e की power x upon y square dy. This equal to 0. So this is x cube by 3 and plus integrating this y square and here e की power x y dx and plus here e की power x dy. Okay. This equal to 0. So what is integration of this? Integration of this one. This is x cube by 3 and plus here. What is this result? This is d of e की power x अपॉन y का होल स्क्वायर, y dx e की पावर x अपॉन y ये इक्वल टू 0. So integrating this, x cube by 3 and plus e to the power x upon y equal to c. This is answer. Denominator differential of numerator e to the power x dx plus numerator differential of denominator or denominator का whole square. Okay, so this answer. Now here this is the complete solution of the question. Method 4. If a differential equation which is not exact, then we apply here method 4. Method 4 is, what is method 4? If given differential equation is not exact, number 1, means condition of an exact is not verified, and type of the differential equation m is of the form y into f1 of function xy. Function xy, in place of x, there is writing xy, and n is x of function of xy. In place of x is xy here. I.e., our question is this type here, y f1 xy plus x f2 xy equal to 0. Means in function in place of x is xy and y multiply. In place of function is xy. Every place in place of x is xy. Xy is a function variable and x multiply here. Okay, so here is dx and plus here is dy. So this differential equation, this is the type of differential equation. Type of differential equation here is in m by multiply function of xy and dx plus x function of multiply xy, x multiply function of xy and dy equal to 0. This is the type of differential equation. In this differential equation, integrating factor IF, integrating factor is 1 upon mx minus ny. 1 upon. This is an IF. 1 upon mx minus ny. Multiply by this function, multiply by this function, then given differential equation is an exact. Given differential equation is an exact, and then we can solve by exact method. Exact method. Okay. Now one problem is there. This is the problem solving. First of all, this is not exact. Okay. If you want to solve this not exact, 100% this differential equation, this is not exact, 100%. 100% exact, non-exact. So now here I am taking IF, integrating factor, 1 upon m is this, m multiply by x, so xy is common, and here n multiply by y, so xy is common here. I am writing this, इसको mx लिख दो, ऐसे सरल बनाओ, थोड़ा इजी. Now mx equal to, m is this, y into xy plus 2x square y square into x, mx. Okay, so now here xy in bracket, xy plus 2x square and y square. Now n mx minus ny, यही है ना फॉर्मूला, mx minus ny, ये गलत हो गया, mx minus ny. We apply here mx minus ny. So ny equal to, what is n? n mx x y minus x square y square into y. So this x y in bracket x y minus x square and y square. So here 1 upon mx minus ny. So this equal to 1 upon, I am writing xy is common here. So xy plus 2x square y square, 2x square y square minus xy plus x square y square. Okay. So xy is cancelled. 2x square y square, 3x square y square. So 1 upon 3x cube y cube. So this is an IF integrating factor. 1 upon 3 x cube y cube. This is an integrating factor. Okay. We multiply y this factor to the question, then question is an exact differential equation. Exact differential equation. Okay. So now multiply by this in each term. 1 upon x cube by cube multiply in question. So I am writing here 1 upon x cube by cube. X cube and y cube multiply to question. What is question? Question is by xy by in bracket में xy plus 2x square y square and into dx plus x into xy x into xy minus x square y square and dy equal to 0. So multiply by this here. Each term we are factorizing each term. So here xy square upon x cube by cube dx plus 2 x square y cube upon x cube by cube dx plus x square y dy upon x cube by cube minus x cube by square upon x cube by cube into dy equal to 0. Every term we break here. Okay. Every factor we multiply this into this, we multiply this, we multiply this. There are 4 terms, 1, 2, 3, 4. 1, 2, 3, 4. Every divided by this term. So what happened? Here x cancel and y square cancel. So here is 1 upon x square y and dx plus here is x pi cube cancel and 2 upon x dx only. X square cancel 2 upon x plus here x square cancel and here y cancel. So dy upon here is x y square. Last term here x cube cancel, y square cancel minus 1 upon y dy here. Okay. This equal to 0. So integrating term. This term is integrating. 2 केवल एक जगह आएगा. So this term integrating and these term are this. So x square y. So x square y square is LCM from this term and this term. So here is y dx and plus here is x dy. Okay. And here is 2 log x and minus log y and equal to c. So integrating this term y dx and plus x dy upon x square y square plus 2 log x and minus log y equal to c. So here this is xy का whole. This result is d of xy upon xy का whole square plus 2 log x and minus log y equal to c. So this is t, integrating this term. So dt upon t square. Let xy is equal to t. So d of xy is equal to dt. So this minus 1 upon t. Integration of this is 2 log x and minus log of y equal to c. So plus 2 log x minus log of y equal to c. So minus 1 upon xy, t is xy, plus 2 log x minus log y equal to c. This is answer. Okay. This is complete solution of the question. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.